Students, problem number 21. This is example from the Narayana NEET book. Problem number 21. You see what the problem is, students. So many of students are facing the problem in calculation and understanding the concepts. Okay. So what they are saying, the electromagnetic radiation of wavelength 300 nanometer. Okay. So that is wavelength they have given how much, student? That is 300 nanometer on the surface of sodium. Okay, on the surface of sodium, this is the one radiation of this is falling on the sodium. This is the Na metal. Okay, on the surface of sodium, electron of emitted with kinetic energy this much. So that is when it is falling here, that is electron will be emitted. Okay, electron is getting emitted, and with the they are saying kinetic energy, how much kinetic energy they are saying? 1.68 into 10 power minus 5. Okay, joule per mole is there, joule per mole. Unit you keep in mind, Mr. M. What is the minimum energy needed to remove an electron? How many electron? One electron from sodium. Okay, so that is what is the maximum wavelength that will cause photoelectron to be emitted, right? So these many things they are asking student. Okay, so first of all we should know that is total number of what is the maximum here, what is the minimum energy needed to remove an electron from one electron from the sodium. Okay, and then they are asking what is the maximum wavelength that will cause a photoelectron to be emitted. So let us move and solve. Okay, so you know one formula, student. E is equal to, that is I am writing firstly formula. E is equal to, that is W plus kinetic energy, means that is total energy of photon. Okay, is used to doing two things. First is increasing the kinetic energy of electron, increasing the kinetic energy, and secondly doing the doing the work, doing the work against attractive forces, against what attractive forces. Now because electron is bonded with the nucleus. Our student, for the one by one, K is given, W we have to calculate. Firstly you calculate the energy. E is equal to what, student? H mu. Mu is, since we know mu is equal to C by lambda. Okay, so this equation will become Hc by lambda. Okay, H value, that is Planck constant, 6.626 into 10 power minus 34, and C value 3 into 10 power 8 meter per second. The energy will come in joule, student. Lambda value they have given 300 into, this is in the nanometer. Now lambda value you check out is the in the watt unit they have given, student. Lambda value 300 nanometer. So 300 nanometer means you all calculate, convert it into meter, that is 3 power 10 power minus 9. Now you solve it out, student. So many students are facing the problem in calculations. I don't know, these 3 and these 3 is cancel out, 2 0 are here. Okay, so you see this the number 6.626 into 10 power, this is minus 34, this is plus 8, this will go in the numerator, plus 9, and this will 20 will go in the numerator, so minus 2. So that is 6.626 into 10 power minus 34, right, student? Minus 34 and plus 2 is there, so minus 34 is there, student. So here I am doing, wait. So if you are seeing minus 34 and these two, okay, both are minus, so that is minus 36 minus 98, that is 17. Okay, so you subtract that one, 6.626 into 10 power 70. If you are subtracting this one, so now 96 that is it will come 10 power minus 19. Okay, 10 power minus 19, this is coming joule. But here energy they are saying, that is in whatever this is given values, this is per mole is given, student. So they that is, this is the energy of, this is energy energy of one, this is energy of this is energy of one photon, energy of one photon. Okay, photon, but they are talking about per mole. So energy of 1 mole photon, how to calculate? Energy of 1 mole photons, how to calculate energy of 1 mole photons? So what will be the answer, student? Energy of 1 mole of photons, so that is E is equal to, that is energy of En is equal to, so that is n into E of one photon, E of one photon, okay, E of one photons. So that is n is equal to, n is Avogadro number, mole you say, or that is Avogadro number, Avogadro number. So that is 6.022 into 10 power 23 multiplied by energy of one photon. Just now we have calculated 6.626 into 10 power minus 9, 6.626 into 10 power minus 19 of joule per mole. So that is for 1 mole. If you multiply out these two students, if you are multiplying, it is coming 3.59 into 10 power how much, 5 joule. This is coming. So that is, this is the total energy, student. This is the total energy of 1 mole photon, of total energy of 1 mole of photon, 1 mole photons, total energy of 1 mole photons. Okay, now next heading, what will be the next heading, student? Next point which we have to solve, student, that is now kinetic energy and total energy we got, so we can calculate the work function. So this equation we can apply, E equal to W plus kinetic energy, right? So W, if you are calculating, student, so E minus kinetic energy. So E, how much is there, student? 3.59. Just now here you calculated 3.59 into 10 power 5 minus kinetic energy. If you see kinetic energy in the question, they have given, student, what is kinetic there, 1.68 into 10 power minus 5. So here we can write, student, 1.68 1.68 into 10 power minus 5, right? So it is coming, that is 3.59 minus 1.68 into 10 power minus 10 power, this is minus, I think, student, this is 23, this is okay, that is unit conversion, not, wait, how much power is there, student? 10 power, here is what is there, 10 power 5, student, not minus 5, sorry, 10 power 5 is there. So this is whatever we are using the term minus, that is wrongly we are using, student. So 10 power, it is there 5, so that is 10 power 5, not minus 5. So you subtract it out, student, how much coming, 2.31 into 10 power 5 joule per mole. Okay, this much we got. अब now, student, how to calculate the minimum energy required to remove an electron? So that is energy required to remove an electron per mole is there. Keep in mind, energy required to remove, okay, an electron. So how to remove, student? Energy required, so that we can apply, this is the total energy, we can apply total energy, total energy divided by what we can do, student, total energy divided by 1 mole, okay, because here per mole is there, 1 mole electron, okay, 1 mole. So total energy, how much we got, student? That is 2.31 into 10 power 5, okay, divided by 1 mole, 6.022 into 10 power 23. So it's equal to 2.31 into 2.31 divided by 6.022 into 10 power 10 power 5, okay, and minus 23. So you see, student, how much the values you are getting. So 19 you will get. Here it is coming 3.84 into 10 power minus 9 joule. Okay, this much is coming. So this is the energy we got, student, energy we got. Okay, so energy we got here, and then what remaining thing they are asking. No, so first of all we got, that is what is the minimum energy needed to remove an electron, we got, student, from the sodium. What is the maximum wavelength that will cause the photoelectron to be emitted? So they are now asking, that is wavelength. Okay, so let us see, student, wavelength, how can you calculate? Now this is not getting erased. Let me erase, student. Here is the place is there, here we are doing, right? So now we know, student, E is equal to hc by lambda. So lambda is equal to what will come, hc by E. E value we have already got, h value 6.626 into 10 power minus 34, C value 3 into 10 power 8 meter per second. E value, just now we have calculated, student, E value, how much we got, that is 3.84. You can check out here, somewhere it was there. here 3.84, this 3.84 into 10 power minus 9, 3.84 into 10 power, it is how much is there, student? Minus 9 or 19? How much is coming, student? 19, not 9, 19. 10 power it will come minus 19, minus 19. Too much time it is taking, student. Long question. This you have to skip this type of question in the exams. Okay, if it is coming, generally it will not come. So this will be 19. Now you solve it out, student. This all numerator denominator you solve out. So if you are calculating 6.626 into 3 upon 3.84 into 10 power minus 34 plus 8 plus 19. So if you solve it out, student, and multiply and divide 5.17 into 10 power minus 34 plus 27, right? So 5.17 into 10 power, 10 power, how much is coming? Minus 7. Okay, this is coming in the meter. So that is how much? 5 point, if you are removing the decimal, student, remove the decimal. If you are removing the decimal, see what will come. 517 into 10 power, what we can write? Minus 9. Okay, so 10 power minus 9 meter is equal to 1 nanometer. 1 nanometer. So at the place of this value we can put the nanometer. So 517 nanometer. So this is the wavelength of the ejected photon, ejected electron. So this is all about this problem, student. Thank you so much for watching. Okay, you need to solve 3-4 times, student, for this question. You don't think that is in the within one time you will be able to solve this. Thank you so much for watching.